Hello guys, this is me again. Now I uploaded my repository with some, let's say, improvements. It's the basic simple line detector in OpenCV. This example that I made here is based on the Udacity self-driving car nanodegree. And let's talk about the composition of the repository. Well, you will have here the examples. There are a lot of image and also the MP4 files about everything that is related to the project. So they use a method, as you will see on the repository, based on color selection and masking. I'm using Kanish detection. Okay, you have the example folder. Here are the test images. Here are the test videos, and I made here some test video output to see how it goes in my case. This folder will have a class. The class is everything you need to do image processing pipeline. For example, here is the class well documented with its with the doc string. And in the end, you will have if you call this file, it will execute this main, and it will show you the output image in the window. Okay, I don't have a very detailed README, that's why I'm making this video. But basically, when you are on the root and start Jupyter Notebook, the Jupyter Notebook must be started on the root, and you will be okay executing every one of the notebooks. I only made a HTML file to see the output of the last complete example, but I hope you can open these things without any problem. So in the end, if you want to test only the let's say the class and show the image that is processing here, well, you have to run this command python sdc lines detector py, and you will be okay. You will be seeing the image like here. Let me say that we can do that. Let's say python sdc here you will see the output window that is the lines detected. So you will press escape or quit, and it will go out. The other thing is that if you want to see the lane lines based on a video, so I made a lane lines detector. Let me show you here. Let's see. Okay, hold on a minute. I will open the file here. Just a minute, because I don't want you to view my let's say the odd things that I have here about my keys. Okay, so the lane lines detector, I will explain it later, but as you see, here is an example of how to initialize it, the video capture and the video writer, and show the process of the pipeline here on a window. That's what we are trying to do in the second command. So here you will see the output window. If you press queue, it will quit, but in the same time it will be saving the video on the output folder. The output folder is the one that I told you later as the test video output folder. Okay, let's move on the repository better. Here, this folder test video output will be stored all the videos that you will process using this command. So now I will explain the notebook. So the notebook is basically the Udacity self-driving cars nanodegree. I downloaded the repository and made some modifications to, let's say, not make it simple, but something a little bit different. Well, as you see, the pipeline is based of loading the images, collecting the edge by gradients using like an edge detector, detecting the lines using Hawk transforms, averaging the lines to get a better estimate, and weight the image and the mask to overlay each one to show the lens. And we're using only matplotlib for graphing, NumPy for array operations, OpenCV for image processing, of course, and OS just only to join in the paths of the image. So you will have the initializer of the class here, the lane lines detector, canny edge detector pipeline that consists of converting the image to grayscale, then blurring using a Gaussian blur and a kernel size. You can specify the kernel size. Also, in the end, when you do the canny edge detection, you will specify the low threshold and the high threshold. And the next function in the pipeline is to get the region of interest. You will feed it with an image, vertices that you are trying to make the polygon, and the color that you are trying to separate. Sorry, it's the color that you're trying to mask. And we will use the complete scale of the color here. So you will create a canvas, zero-light canvas of the main image. Then you will fill the polygon using the vertices that you've been specified here. And in the end, you will do a mask and return that mask. Later, you will use the Hawk transform to compute the probabilities of points that are separated by the region of interest and the mask. So you will specify the resolution in pixels and the angular resolution in radians, also the minimum number of intersection and the number of pixels that will make the line, and the maximum gap of pixels between each connectable line segment. Next, I made two functions. One is simple. You just collect all the lines and put the graph a line between each point detected until you get to the last line detected. So you will put it a color and a thickness, and the same here. But the other approach that I'm using here is that if you see the left line or the right line. So if you are on the red line, the left line, the slope is negative, and I am passing those parameters to the getCourse function. Don't look too much here. That's because I was too lazy, and for some examples, because we are cropping a region, we get a mistake. So that's just for exception handling. Don't get a lot of isolation of that. Just a simple example. In the end, I will put the points over the image, the left line and the right line. On the get course, it will try to put the based on the parameters that are the slope and the intercept, recalculate the positions and return back a couple of points. That's what I'm doing here on get course. So the pipeline is pretty easy. You will set up everything, and in the end you will do the candidate architecture. You will select the region of interest, then compute the lines, and in the end you will select which kind of visualization you want, the simple R or the weighted, or the lines that will be processed by the slope and intercept. That's the simple one, and that's the average one. So let's start out with an example. For example, if you get this image that is on test image named challenge, you will see that everything is okay with the right color. Then you do a candidate detector. I made the X and Y ticks on the image of 20 steps to just calculate everything. And when you select the vertices, then you get the region of interest. As you see here on the original image, you have here like the front of the car, so we have to select between 600 and 700. And also when everything is cropped, you will see this region only, this thing here. Okay, when you got this, then you process use the hog probabilistic transform, and then you will get with these lines here. And finally, when you are using the average lines, you will end with these lines here. When you weight everything, you will get this beautiful image with the lean lines detected and everything marked over the original image. So testing the pipeline by hand, you select every image that you want to test here. You change everything here, and you can test the algorithm for each image. But for when you're using OpenCV, little mistake here, sorry. I made this, let's say, fixed examples. If you are using challenge, you will have to enable those lines and disable these lines. If you are using solid white right, then you enable these lines and disable these lines, for example. And for each one, you have to tweak your parameters. For example, I made a copy here of all the parameters that work for me for each example, and that's all. Everything is recorded and put on the output. So if you want to, let's move to the OpenCV function. Let's move it. Sorry, the OpenCV function, no, the class. The class is the same thing. I just made you a class for easy use. So you have here the same class that you saw on the IPython notebook. And in the end, as I told you, you get an example of how to initialize it and how to use it. The same here for the lean lines file that is on the root, how to initialize it and how to use it. Then, for example, I also made a requirement file using Anaconda. Using Anaconda, that's the pip freeze output. But in the end, you only need Matplotlib, NumPy, and OpenCV. Obviously, Python. I don't remember if I'm using version 3.6 or 3.8. Don't remember really well right now. And that's all. Let's say then the output on YouTube, and you can see this output here. Let's see on my channel. Hold on a minute. Okay. I think we are okay. Okay, here is the okay. Okay. When everything goes wrong. Let's move on. Okay, here is the final result. As you see, let's play again. You will see this not neat video, but really explaining full about how to detect route lines. I hope you get very well know how to use OpenCV and how to use my folder and everything that you are doing related to the project is based on each one of these, let's say, simple examples. So practically, if you follow all those examples, you will understand how and why I made those decisions on the detect lines IPython notebook. So that's all. I hope you liked all the information that I put here. I will try to implement a good documentation later, not this week, probably the next one. That's all. Okay, thank you and bye bye.